All right, let's dive into a really core idea in geometry called congruence. It's basically the fancy math way of asking a super simple question. When are two shapes exactly the same? You can look at two puzzle pieces and just know they're identical, right? Or maybe two tiles on the floor. But how do you say that with, mathematical proof? How can you be 100% sure? Well, that's where geometry comes in, with a really powerful tool for us. Because let's be real, in our everyday chats, same can mean a lot of things. But in geometry, we need to be way more precise. We can't just go, they look the same. Nope. We need a word that means they are identical in every single measurable way. And that word, it's congruent. So here's the official definition we're going to work with. When two shapes are congruent, it means they are perfect clones. Literally. If you could somehow pick one up, you could lay it right on top of the other one, and it would match up perfectly. No gaps, no overlaps. Okay, so what does that actually mean? Like, how do we check? Well, it boils down to two super simple rules. For any two shapes to be truly congruent, two things have to be true. First, all their matching sides have to be the exact same length. And second, all their matching angles have to be the exact same size. It really is that specific. But this brings up a really interesting question. What happens if you move the shape? I mean, what if you flip it over, or spin it around, or just slide it across the page? Is it still the same shape? Of course it is, right? This is where we get into three special moves in geometry that are called transformations. All right, let's kick things off with our first move, the flip. Or if you want to get technical, it's called a reflection. And a reflection is, well, it's exactly what it sounds like. It's a mirror image. Just imagine a mirror line running down the middle. The shape just flips right over it. You end up with the exact same shape. It's just facing the opposite direction now. So pause and think about that for a second. Okay, it's pointing a different way now, but did anything really change about the triangle itself? Are the sides any longer or shorter? Do the angles get bigger or smaller? Next up, move number 2, the spin. The official math term is rotation. The best way to think about it is like sticking a thumbtack in the middle of a shape and just spinning it around that point. So you can see here, we took that rectangle and just gave it a 90-degree turn around its center. It's the same rectangle for sure. It's just standing up instead of lying down. And here's that key question again. We spun it, right? But did we actually change the rectangle? Did we stretch it out? Did we squash its corners? Is it fundamentally the same rectangle? And our last move is probably the easiest one of all, the slide, or as it's officially called, a translation. All this is just sliding a shape from one place to another. No flipping, no spinning, just a simple slide. And you can see what happened here. Every single point on that pentagon moved the exact same amount in the exact same direction. It's literally just in a different spot. So, one last time, let's ask the big question. Did sliding it change its size or its shape? And the answer to this question, which we've now asked 3 times, is the whole key to connecting these moves back to our big idea, congruence. And this table just lays it all out perfectly. Look at this. The reflection, or flip, did it preserve length? Yep. Did it preserve angles? Yep. So the result is congruent. Same for the rotation, or spin. And same for the translation, or slide. In every single one of these moves, the basic DNA of the shape, the length of its sides, the size of its angles, stays exactly the same. And that right there is the big takeaway, because a flip, a spin, and a slide don't change the size or the shape. The new image is always congruent to the original. This is a huge, huge concept in geometry. And hey, this isn't just some neat trivia. It's a major learning objective. The Cambridge curriculum is super clear about this. You need to know that shapes stay congruent after you do these transformations. It's a real cornerstone of the subject. And you can see right here where this all fits in. Look at this. Unit 17 of the course book is called Position and Movement, and it's all about this stuff. Reflecting, rotating, translating. This just goes to show how central these ideas are if you want to really get a handle on geometry. So let's end with this. Why does any of this matter outside of a math test? Well, this whole idea of proving two things are identical is a building block for pretty much everything. Think about it. From making sure car parts fit together perfectly on an assembly line to designing the characters and worlds in your favorite video games, it all comes back to congruence.
The simple rules we just talked about, they are literally helping to design the world all around us.